Good morning, ladies and gentlemen. A warm welcome from Germany to our webinar, Automated Turning. My name is Taigan Quarry. I'm Head of Engineering for chuck parts and CV joints. I'm working now 20 years at EMAG. Today with me in the studio is Johannes.
I also want to welcome you. My name is Johannes Mautz. I am head of the team Automation and Robotics, and I am working for the EMAG since 7 years now.
Thanks, Johannes. So before we start, one information for you. Please use the chat function in your browser so you can send your questions to us directly in this live webinar, and we will answer it directly here in the studio today. Okay, let's start. Automated turning. So first of all, we want to show you what are the main topics today, what we will present you. So first of all, I will present the TrackMotion automation system for you and our solutions for that. After that, I will present also the gantry automation solutions from EMAG, and the robot automation system will present Johannes. Johannes will present also the SCS stacking cells, and at least he will show you our customized automation solutions from EMAG. Okay, so the TrackMotion automation system. I have here a picture of our TrackMotion. You can see here our translift. And our translift is running on a rail system, so we call it tracks. On the left side, you see the control unit of the TrackMotion system. Here, a bigger picture of the translift that we know a little bit better. So we have here a Z5 axis. So this is the axis to drive up and down. And we have here our turning unit. We call it D5 axis. And also the electric grippers for clamp and unclamp the parts. That's the U5 axis. So on the right side, you can see the technical data. I don't want to explain each point, only the important points. So we have two different sizes for our translift. So the TM420 and the TM870. And the difference, what we can do with these two translifts are the max workpiece diameter from 200 to 400 millimeters, the max part height from 200 to 300 millimeters, and the max part mass from 20 kilogram to 70 kilogram. Here, a live picture of our translift. So you can see here directly. So the translift is equipped with a Z-axis that's lifting up to 650 millimeters. And the gripper can turn over the parts to 100 degrees, from 0 to 180 degrees. And for example, you can make a turnover also to 90 degrees. We have two available gripper sizes with two sets of jaws for the maximum workpiece diameters of our VL series. If you need any other jaws, for example, for your part, we can design it and can deliver it with the TrackMotion system. Here another picture of our TrackMotion system. So you can see in one system we have conveyor belts, pick and place units and turnovers in one single system. Here in this example you see a stacker conveyor. So that means we can load a lot of parts. So here in this example we have around about 200 parts for loading. So that's very good for the footprint. The TrackMotion is equipped with its own control unit that communicates only via an interface with the machines. So that means the TrackMotion have his own control unit and the machine have his own control unit, and we are connecting together with the interface. The TrackMotion controls also the in-feeding and out-feeding conveyors, or in this example, the stackers. So here another example of a line, of a TrackMotion line. We have here 3 VL8 machines. The first one is the operation 10, the second one the operation 20, and the last one operation 30. So as you can see, it's a very lean assembly line, so we have a very small footprint. And also a very big advantage, so that means we can interlink a lot of machines, here in this case 3 machines together, very easy with our TrackMotion system. Here we have now a question. So how is the TrackMotion programmed? Does the automation have its own control system, or does it run via the machine control system? That is what I have explained before. So yes, the TrackMotion have his own control unit and his own program. So that means it's completely disconnected from the machine. So, and you can make the program on the TrackMotion, and we are connected with the machine only via an interface. And that means it's running by himself without any other control unit from the machine. Okay. So here I have shown you another picture of a TrackMotion line. You can see here very good the raw part conveyor with stackers, and the finished part conveyor here very small, also with stackers. So that means here in the front you can load around about 200 parts, and at the end also 200 parts, finished parts. So the biggest advantages what we have for our TrackMotion system is the minimum changeover time. So you need only to enter the workpiece height and the diameter, and the TrackMotion is directly ready for the operation. We have also high reliability, so because of simple and sturdy design. Also a big point is the cycle time. So for that we design a very fast automation. We are reaching speeds horizontal round about 150 meter per minute and vertical 25 meter per minute. Also a big advantage for the cycle time is that the TrackMotion system make the positioning and the turning over of the workpiece in one operation. Big point for footprint for the customers is the footprint. So we saving a lot of space with our TrackMotion system because it's installed internally behind the machines. If you have any measuring devices, marking systems, or cleaning machines or whatever, it's very easy to integrate in our TrackMotion line. The TrackMotion will load and unload all these additional functions. Also a big point for our customers is the service. And we have designed here a good solution, so it's very easy to service it. You can reach the translift and the rail system or the track from all sides. So we have here doors, a lot of doors to go inside and to service the TrackMotion. Here a video of a VL3 Duo. So on the left side the operation 10, and on the right side you can see the operation 20. So here we load with our picker system in the machine area the part. Here we are machining the part. That's a turning process. Operation 10. After that we are checking this part with the measuring probe of the machine, unload on the pickup system and load the new raw part. The semi-finished part is going outside. The TrackMotion is ready for loading a raw part for the operation 10. Takes the semi-finished part, makes the turnover to the next operation, takes the finished part, makes the turnover back and unload on the stacker system. Then he take the next raw part directly. So here you can see operation 20, we unloading the part, take the new part for the machining, and the finished part is going outside to the TrackMotion for load and unloading. So here a very good example for a small footprint together with our TrackMotion system and our VL3 Duo with 2 operations. The TrackMotion system is doing here the turnover, the loading, unloading with stacker. So it's a very good solution from EMAG. Here again, a video with our TrackMotion system. That's the same example as before, a VL3 Duo. Now we have a GoPro on our translift. So we load the raw part, makes the turnover with the semi-finished part for the next operation. And then we take the finished part, makes the turnover back and unload on our stacker system. So you can see here on the right side, only finished parts. And on the left side, we have the raw parts. So we have this separately. Okay, we have a new question. What happens if the TrackMotion fails? Can production continue independently of the automation? Yes, that's a good question. For example, we have 4 machines, 4 VL8, for example, and 2 of them are operation 10 and the other 2 are operation 20. If, for example, one operation 10 have a failure and we can't run this machine, we can produce with another one, and the TrackMotion will load only the second machine. So in this machine we can put completely outside of the line. So the TrackMotion is not loading anymore this machine, and the line can run again. Yes, that's possible. Okay. Here, a bigger line with our TrackMotion system. You can see here in this example, it's a diff case. So we have here a raw part conveyor. The TrackMotion is loading the raw part for the first operation. We're machining it in the first operation. After that, the TrackMotion is again ready with the raw part, takes the semi-finished part and loading the next operation. So here we make the machining of the other side of the diff case. Then the TrackMotion takes it, unload on the next machine. In this example, we have a VT4, so it doesn't matter which machine type, the TrackMotion can load and unload. So that's a very good and easy solution. So you can see we can interlink a lot of machines together. Here we make the turnover to 90 degrees, not to 180, because we need for the diff case the 90 degrees to machine the ball inside. Here you can see measuring system. So the TrackMotion makes the loading and unloading of the measuring system. And after that, he takes the finished part and unload on the finished part conveyor. Good. So this was the first point, TrackMotion automation system. Now the next point is gantry automation solutions from EMAG. So here in this example, I have put 2 gantries inside. So one is the LP150 with a maximum transportation load of 150 kilograms and the LP40 with a maximum transportation load of 60 kilograms. Our gantry loaders are high performance, low maintenance automation systems for chuck components and shafts. We have a range of accessoires and extensions for the 2 gantry loaders, from pneumatic or electric grippers to a second carriage if it's needed. So for example, you need 2 carriage for 2 different parts, then it's also possible, or to save cycle time and we need the second carriage, it's also possible to implement in this solution. Rotary and swivel unit is also possible, and the gantry itself moves via a rack and pinion system, which not only guarantees high positioning and repeat accessory, but it's also very robust. Here an example. So you can see here we have 2 VSC 400 duos. So on the left side we have 1 VSC 400 duo, and also on the right side VSC 400 duo. So this is a brake disc line. So on the left side is the operation 10, then the operation 20, operation 30 and operation 40. Our gantries are here and here. So our gantry performs several functions in this example. So our gantry is doing the turnover between the operations. So that means, for example, between OP10 and 20, we need the turnover. The gantry is doing this job. And also what is possible is that the gantry outsource and insource SPC parts. So he outsourced the SPC part, the worker is checking the part. If everything is okay, he can put again inside and the conveyor will insource the SPC part. It doesn't matter from which operation, it's possible for OP10, OP20, OP30 and OP40. So, and also what he's doing is to placing the parts after machining on the conveyor belt. We have a question now from the viewer. How are the machines set up? Are all machines stopped during setup or can a machine be removed from the production process? Or are the machines set up? Are all machines stopped during setup or can a machine be removed from the production process? Yes, so we can put one machine outside during setup. Okay. No. So what we can do is to put it outside from the line and run with the other machines. That's also possible, of course. Yeah. So here I want to show you, that's the same example. That's a brake disc line. You can see here our shuttle and also the buffering conveyor. So what we designed the gantry inside this line that we don't lose too much floor, so that floor space. So that means also a good advantage for the footprint of our gantry automation solution. Also a big advantage of our gantries are that we don't need our own control system of the gantry. So that means we put the axis on the machines or the control for the machine from the machine control. So we're saving a lot of costs. Also configurable for every user case. It doesn't matter what you need. So if you need a turnover of the part or not, we can do it or implement everything in this gantry solution from EMAG. Here a video. We're taking the part, clamping with our gantry, makes a turnover to put the chips out the brake disc. And after that, we unload on our conveyor belt. Then the gantry is ready to make the next job, to take the semi-finished part and to make the turnover for the next operation. So that was the first 2 points from my side. The next point, robot automation system, will present you Johannes. Thank you, Johannes.
All right,
please.
Thank you, Daigan, for your presentation. Now I want to introduce our robot automation cells. They are fit perfectly to our EMAG machines. They can mount on the left-hand side or also on the right-hand side of the machine. It's also very easy to retrofit an existing machine of us. And our cells consist of a base plate with robot and also with an electrical cabinet included. We have an entry door on the back side to enter the cell and do the maintenance, for example. And also it's possible to integrate an additional unit like an SPC drawer or maybe a blow-off station. We are mainly work together with a KUKA robot, but also FANUC is possible for us. We have 3 different loading situations, and here we can select the best situation for our customer requirements. In these 3 situations, I want to introduce you now in detail. We have the basket stacks, we have a drawer system, and also the infeed with the bin picking solution. Here you can see our basket infeed solution. It's possible to have up to 3 loading bays. we can include the baskets or the trolley of the customer. So yeah, we can use the already existing baskets from the customer. Here is shown the size of the baskets are 400 to 600 millimeters. And the stacking height of the baskets can be 1000 millimeter. The parts are orientated in the baskets. Therefore, we don't need a camera for the robot. And here you can see the robot will unload the raw part and feed the pallet of the OP10 of this VL3 duo machine. And also the robot will turn over the part to the OP20 pallet. And after that, the raw part, the finished part will unload to the basket again. The robot is also prepared to unload the empty basket to the different bay.
Johannes, we have a question now.
Okay.
When is which automation system used?
Okay, I think the viewer wants to know which of our 3 loading systems.
I think so, yeah.
So in this case, we are talking directly to our customer, and we are choosing together the best solution. For example, this stacking cell solution, if the customer already have some baskets inside his plant, then I think it's a good solution to integrate his baskets and trolleys. And yeah, but we have always to discuss it directly with the customer and decide together.
Okay, thank you.
You're welcome. Okay, now I will continue. Here you can see our drawer system. We have 2 big bays in the front. Each bay can have up to 4 drawers, but that amount it depends on the part height. Each drawer can have 2 workpiece carrier, and the worker can load these workpiece carrier directly or externally and load a completely workpiece carrier to the drawer. The robot continues its work inside because they are completely in different areas. So we have a closing door. As you can see, also the robot will unload the raw part out of the pallet and load it to the machine. The robot turn over the workpiece to the OP20 and unload the finished part directly to the workpiece carrier on the drawer. In the backside, you can see an SPC drawer. Here it's possible to outfeed the SPC parts and also to feed them back in to the system. Now I'm showing you our bin picking solution. Here we have 2 big bays in the front. Here on the right hand side you can see the bulk material container. The size could be maximum 800 to 1200 millimeters. Above that container we have a 3D camera. That camera recognizes the parts and also the orientation of the part. Then it's possible for the robot to grip the part out of that container and load the machine. In this example, we also have an VL3 duo machine. So the robot will load the raw part, turn over the part to the OP20, and then unload the finished part directly to the second box. Now here you can see the first layer of parts is full. So now the robot can automatically change the gripper and put a layer inside the box. And then the robot can unload the next finished parts again to the box.
Okay, Johannes, we have the next question. How flexible is bin picking when changing workpieces? Does the camera system have to be retrained?
Okay, that's a very good and interesting question. Thank you. So if a part is already trained to the system, or maybe two parts, then you can just select the different program inside the control. If the customer brings in a very new part to the system, then of course you have to train this new part to the system. And after that, you can just change the program to the different part.
So a new part, one time, you need to retrain, and then after that, you don't need to do that for this part anymore.
Yes.
Okay, good. Thank you.
You're welcome. Okay, now I'm showing you our stacking cells of the SES series. They are also fit perfectly to our VL and VT series, and also to our hobbing machine of the K series. It's also possible to retrofit existing machines and automate them. We have here two sizes of machines. The first is the SES1 machine. It's for the smaller workpieces up to a diameter of 200 millimeters. And we have the SES4 machine. This machine is for the bigger parts to a diameter up to 400 millimeters. Here you can see an SES1 cell mounted to an K160 hobbing machine. We have a loading door in the front, and again our drawer system included. Also, we have the opportunity to load 4 drawers inside, and each drawer can handle 2 workpiece carrier. In the middle, you can see a door. This door will separate completely the worker and the robot. The robot will unload directly out of an internal loading gantry of the machine and loads the parts to the workpiece carrier. And if a workpiece carrier is full, the robot can automatically change to the next drawer. You can see the SES1 is a very small and compact automation solution with robot already included. We have an housing, and also the electrical cabinet is included. In the front and in the back side, we have a door, so you can enter the cell to maintain the robot.
Johannes, we have the next question. Do you have experience with unmanned production? Can the machine produce an entire shift fully automatically? How do you deal with faults during production? Automatic notification.
Okay, that's also a very good question. Yes, we have experience with unmanned production. Here it always depends to the system. So it depends how high is the amount of the actual raw parts are available, if it reaches a whole shift. And also it depends on the tooling of the machine. So maybe we have to change the tool after its tool life. But also we have solutions like sister tools inside the machine. So we are delivering solutions for that. And also for the automatic notifications, we can integrate our Etna IoT system to the customer solution, and then it's possible to get the notifications out of the machine.
Thank you.
You're welcome. Okay, now you can see our SES4 cell. Here we also have a very big opening door in the front. Here the worker can feed in a stack of pallets of baskets with a forklift, or maybe like here shown in the video, it's also possible to load via HGVs. The SCS4 has an internal loading gantry, and that gantry will sort the baskets to its different areas. So we have an area for the raw parts, and we have an area for the finished part baskets. And also we have our transfer areas in the top of the machine. Here we can integrate an external automation, like a robot or also a gantry is possible. The robot will unload the raw part out of the baskets of the machine and directly loading a machine, like here shown a VT200. And after that, the robot will unload the finished part back to the finished part basket of the SCS4. And the worker then can take the whole stack of the baskets out of the machine. Okay, now I will present our customized automation solution. Here we are preparing solutions for special customer requirements. We can interlink a lot of our EMAG machines out of our portfolio, but it's also possible to integrate third-party machines if they are needed for the process of the part. And our task is to choose the best automation solution for the machine to handle the parts. And here I brought to you 3 proposals, which we are already designed together with our customers. And these 3 solutions I want to present you now. The first one is a line of 3 VL8 machines in a line. 2 machines are producing the OP10 and 1 machine is producing the OP20. A robot will load the part to the L shuttle of the machine. The machine will unload the semi-finished part to the conveyor and grips the new raw part. And after that, the machine will load its production area and produces the part. After that, the finished part of the OP10 will go outside to the robot. The robot will turn over the part for the OP20. And here you can see the OP20 machine is very far away from the OP10. Therefore, we have to mount the robot on a 7th axis to reach the OP20 machine. Again, the robot will load to the L shuttle of the machine. The machine will unload the finished part to the L shuttle and load the OP10 part to the working area. Now you again can see a short sequence of our process for the part. After that, machining the part, go outside to the robot area. Here the robot again turn over the part, load it to a blow-off station and also to a marking unit. And after that process, the robot will load the finished part to a finished part pallet. Here I have the next solution. It's a very big and complex production line. We are having here 4 machines in the front. Each of that 2 will be loaded by a conveyor belt. And also in the backside we are having a TrackMotion, which will turn over the part for the production. Here we have a connection conveyor. Of this conveyor, the gantry loader will grip the part, load a blower station and also a measuring unit. Then the part go inside a robot cell. This robot will load a hobbing machine. And after that process, we have a pallet conveyor belt in the back. And here we have a very long gantry loader, which will load several different turning machines of us. And at the end of the line will unload the completely finished part to the basket of a SCS4 cell. And the worker can then outfeed all finished parts in the basket in a stack. Here you can see a pure repacking cell. We have 2 SCS4 machines. Each of the machine has a robot integrated. The robot will unload the baskets of the customer and load the parts to a hardening basket. A gantry loader between these 2 machines will handle the loaded hardening baskets and will transfer the baskets to a hardening machine or unit. After the hardened parts came back to the cell, the second robot will unload the hardened part back to the baskets of the customer, again in the top of our SCS4 machine. And then the internal gantry loader will sort the finished hardened parts back to the loading door of our SCS4, and the worker can outfeed all the parts in a stack. Now we've reached the end of our webinar. We want to thank you for your interest in our automation solutions. And we also want to thank you for your very good questions. I think there was a few one. And yeah, thanks for your time.
Thank you also from my side. Thank you for your time. Thank you for your interest. Thank you, Johannes.
Thank you, Dygant.
So if you have any further questions, we will send you after this webinar our mail address directly. You can contact us directly with your questions, and we are excited for the new questions, and hopefully we can give you a good answer, and we see you soon. Thank you.
Thank you from my side.